The composition of an atom can be represented symbolically as ZXA, as shown here. The symbol X represents the symbol of the element. The superscript A on the left-hand side of X represents the atomic mass number, and the subscript Z on the left-hand side represents the atomic number of the element. As you have learned before, atomic number Z gives the total number of protons present in an atom, while the atomic mass number gives the total number of protons and neutrons present in that atom. Let us work on a simple problem before proceeding further. An atom has 29 electrons and 35 neutrons. Calculate the number of protons and the mass number of the element. Also write the complete symbol for the atom. Since atomic number Z is equal to number of protons, which is also equal to the number of electrons in the atom, we can say that the number of protons is 29. We know that mass number A is equal to the sum of the numbers of protons and neutrons. Hence, the mass number of the given element is equal to 29 plus 35, which is equal to 64. Since the atomic number of the element is 29, the atom is copper. The complete symbol for the atom may be represented as shown here. In some cases, atoms of the same element may have the same number of protons, that is, the atomic number, but may have different numbers of neutrons. In other words, the atoms have the same atomic number but different mass numbers. Such atoms are called isotopes. Isotopes of the same element occupy the same place in the periodic table because they have the same atomic number. Let us look at a few examples of isotopes. 99.985% of hydrogen atoms contain only a single proton in their nucleus. This isotope of hydrogen is called protium, 1H1. Remaining 0.015% contain two other isotopes, deuterium, which contains one proton and one neutron, and tritium, which contains one proton and two neutrons. You can see that all these three isotopes have the atomic number 1 and mass number 1, 2, and 3 respectively. Carbon has three isotopes with mass numbers 12, 13, and 14 respectively. Similarly, chlorine, atomic number 17, has two isotopes with mass numbers 35 and 37. Isotopes of the elements other than hydrogen do not have special names. They are represented by simply indicating the mass number on the element's symbol. The chemical properties of an element depend on the number of electrons present and their configuration within an atom, and not on the number of neutrons. Hence, as the isotopes have the same number of electrons, they exhibit similar chemical properties. However, as the mass of isotopes differ due to the different numbers of neutrons present in an atom, their physical properties differ from each other. Some atoms of different elements are found to have the same mass number but different atomic numbers. For example, 18Ar40, 19K40, and 20Ca40 have same mass numbers but different atomic numbers. Such atoms of different elements having different atomic numbers but the same mass numbers are called isobars. Isobars have different chemical properties because they have different atomic numbers.